Hello everyone. Today shall discuss about gravitation, the force that shapes the universe. Two models, one sky. For millennia, humanity sought to explain the regular, repeating motions of the planets against the backdrop of fixed stars. Two primary models emerged, setting the stage for the scientific revolution. The Ptolemaic system. Earth is the fixed center of the universe. The sun, moon, and planets revolve around it in complex circular paths. Ptolemy's model, proposed 2000 years ago, used circles moving on larger circles to fit observations. This is Earth, Moon, Mercury, Venus, Sun, Mars, Jupiter, Saturn. And this is epicycle, retrograde motion. This is retrograde motion, epicycle, like this. And this is Copernican system. The sun is the center of the solar system proposed by Nicholas Copernicus. This is more elegant model. It placed the planets, including Earth, in circular orbits around a central sun. The observer Tycho Brahe, 1546–1601. A Danish nobleman, Tycho Brahe, understood that to solve the celestial puzzle, astronomers needed better data. He dedicated his life to a single monumental task, recording the precise position of the planets. He conducted decades of meticulous naked eye observations from his observatory Uraniborg. He compiled data. His compiled data was far more accurate than any that had come before it. His unprecedentedly accurate data would become the key to unlocking the solar system. The analyst Johannes Kepler, 1571 to 1640. Brahe's assistant Johannes Kepler was a mathematical prodigy tasked with making sense of the master's lifetime of observations. After years of relentless calculation, he discovered that the planets' movement were not random, nor were they the perfect circles of the Copernican model. They followed three distinct, elegant laws. From 2 decades of raw data, Kepler extracted three timeless laws of planetary motion. He discovered how the planets moved, setting the stage for Newton to explain why. The one, orbits are ellipses, not circles. All planets move in elliptical orbits with the sun situated at one of the foci. This law was a profound break from the Copernican model, which still assumed circular orbits. The ellipse is a stretched circle with two focal points f1 and f2. The sun is not at the center but at one of the foci. This is perihelion. The point in the orbit closest to the sun. Aphelion, the point in the orbit farthest from the sun. Semi-major axis. Half the distance between perihelion and aphelion is the semi-major axis. A planet sweeps equal areas in equal times. A line that joins any planet to the sun sweeps equal areas in equal intervals of time. This is area 1, this is area 2. If delta is equal to del 2, then area 1 is equal to area 2. This law means that planets move faster when they are closest to the sun at perihelion and slowest when they are farthest away at aphelion. This phenomenon is a direct consequence of the conservation of angular momentum, a principle that applies to any system under a central force. A harmony of the spheres. The square of the time period of revolution of a planet, t square, is proportional to the cube of the semi-major axis, a cube of the ellipse traced out by the planet. T square is directly proportional to a cube. Kepler's law in action. The ratio t square by a cube in 10 to the minus 34. Mercury, Venus, Earth, Mars, Jupiter. The ratio to square by a cube remains remarkably constant, confirming a universal rule governing all planets. The unifying insight from a falling apple to the orbiting moon. Isaac Newton, 1643-1727, knew of Kepler's laws. They described how planets moved but not why. Legend says that watching an apple fall inspired his great leap of logic, the same course. He theorized that the moon is constantly falling towards the earth, just like the apple. Its sideways motion keeps it from ever hitting the ground. He proposed that the very same force governed both the apple and the moon, a force he called gravity. This idea unified terrestrial and celestial mechanics for the first time in history. The universal law of gravitation. Every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. F is equal to capital G m1 m2 by r square. F is the gravitational force of attraction. m1 the masses of the two objects, the force is proportional to their product. R the distance between the centers of the two masses, the force weakens with the square of the distance, the inverse square law. The gravitational constant, a fundamental constant of nature, its value is 6.67 into 10 to the power minus 11 Newton meter square per k square. This is the universal law of gravitation. The law's power, weighing the earth. The connection. Newton's law can be used to understand the acceleration due to gravity g at Earth's surface. For an object of mass m on the surface of the earth, radius re, the force is F equal to mg. The derivation. Start with the Newton's law. Capital G, capital F equal to g, m mass of earth, in m small m, re, radius of earth whole square. Set it equal to the force we observe mg equal to capital G, capital mass of earth, small m, re square. Cancel mm to find the formula that g equal to capital G me by re square, or m equal to g re square by capital G, mass of earth. Historical note. In this way you can find the mass of earth also. Historical note. Once Henry Cavendish first measured the value of G in 1798. With G and re already known, humanity could weigh the earth for the first time. Gravity is strongest at the surface. You see here, whenever we go to the inside the earth, gravity is strongest at the surface, maximum at the surface. Outside the earth is inversely proportional to r square. In this way it will decrease. Right? Let us find the acceleration due to gravity g changes with position above the surface. As altitude h increases, the distance from the center re plus h increases and g decreases proportional to 1 by r square. As altitude height increases, the distance from the center re plus h increases and g decreases proportional to 1 by r square. Outside the earth is directly proportional to 1 by r square. Below the surface, as you go down to a depth d, the outer shell of the earth's mass no longer exert a net gravitational force. This causes g to decrease linearly as you approach the center, where it becomes 0. At the center, the g becomes 0. At the surface, you see that is 9.8 meter per second square. Inside Earth, g is directly proportional to r, and outside Earth, g is directly proportional to 1 by r square. Here you see distance from center, r equal to 0. In this way, find this one. The force of gravity is at its maximum r equal to rg of the surface of the earth. The maximum value is 9.8 meter per second square. As we go towards the center of the earth, the value of g decreases. If we go outside the earth, the value of g decreases according to g, value is 1 by r square. In this way, it decreases. So the maximum value is at the surface. The energetics of gravity, potential and escape. Escape velocity. The minimum initial speed an object needs to completely escape the gravitational pull of a celestial body. Escape velocity is root over 2 g mass of Earth by radius of Earth. Earth's escape velocity is 11.2 km per second. Gravitational potential energy. The energy stored in an object due to its position in a gravitational field. It is negative for bound systems and becomes zero at an infinite distance. Zero energy at infinity. B equal to minus g m1 m2 by r. This is surface energy must be added to move up the well. Moon's escape velocity 2.3 km per second. This is why the moon has no atmosphere. Gas molecules can easily escape its gravity because in moon the escape velocity is very less, that is 2.3 km per second. Putting gravity to work. Earth's satellite. Principle. Earth's satellite are objects in a continuous state of free fall. Their orbital motion is a perfect balance between their forward velocity and the gravitational pull of the Earth. The physics for a satellite in a circular orbit, the centripetal force required to keep it on its path is provided entirely by gravity. M square by r equal to capital G m by r square. Kepler's law revisited. This relationship leads directly back to Kepler's third law. The orbital period t of a satellite is given by t square equal to 4 pi square by g r cube. Fact: for a satellite in low orbit h tends to 0, the orbital period is approximately 85 minutes. This is centripetal force F. This is force of gravity. In this way, how it works? The energy of a stable orbit. Components of orbital energy. Kinetic energy always positive, half m square g m by 2r. Potential energy always negative for a bound orbit, p minus g m by r. Total energy, the sum of kinetic and potential energy, that is equal to minus g m by 2r. The key relationship. In a stable circular orbit, the total energy is always negative. Furthermore, the magnitude of the kinetic energy is exactly half the magnitude of the potential energy, equal to minus kinetic energy or equal to half of potential energy. This is kinetic energy, zero energy, potential energy, total energy. This is orbital energy balance. From mystery to mastery. Ancient astronomers like Ptolemy observed the heavens and tried to explain their motion. Tycho Brahe data allowed Johannes Kepler to uncover the hidden mathematical laws of orbits. Isaac Newton provided the ultimate explanation, a universal law that unified the cosmos. We now use this knowledge to place satellites in orbit, explore the solar system, understand the universe. The story of gravity is a story of our quest to understand our place in the cosmos. Thank you everybody for watching this video.